I'm just about to go over the homework here, so just so you know what we're doing. Okay, so let me give you that. So we are going to do this, sort of like our notes together,
Okay.
and then the homework.
Okay. All right.
I'm sorry.
Will be, should I just do all the homework or will it be like?
Check on Jupiter
Okay.
and whatever I
Got it,
assign
okay.
out for the day.
All right. Thank you.
Thank you. Have a good weekend. All right, everybody. So, at long last, let's see what we have going on here. So I asked you to do just the evens. So up at the top, you were supposed to draw for me the parent function and then go ahead and do any translations that are required of you. Hopefully you remember what the parent function looks like for x cubed. Okay, is everybody with me? Yeah, it's like this, sort of like the snake creeping up here. And if you don't remember, so what? Plug in some points. Everybody listening? If you plug in 0, 0 cubed is 0. If you plug in 1, 1 cubed is 1. If you plug in 2, though, it's 2 cubed. 8. That's how we get up so quickly. So 2, 4, 6, 8 would be way up here. Don't forget your negatives. You can cube negative numbers. -1 cubed happens to be -1. And -2 cubed would be way down here at 8. So we get sort of this snake-like graph. Okay, so there's y equals x cubed. Now, if you look at this one, they are asking us to perform some translations to this. What does this minus here do to the whole thing? What am I essentially doing?
You're basically doing like opposite.
Of
Not the
what?
opposite, you're-
Basically.
It's a negative slope. and over the back.
You're going to, this is how I do it. I see a negative there.
Oh, multiply all your x values by
You're close.
y values.
Yes, multiply y's by -1. Now, how do you know if that one applies to the y's or the x's? Now, listen, the function is y equals x cubed, right? So if I want to do something to the x's, it's going to have to be in there with the x. So in other words, if I wanted a negative x, I'd have to have it in parentheses, and the whole thing would be getting cubed. So I'd have negative x in parentheses cubed. That's how I know something's happening to the x's. I think in this one, it actually, we got lucky because it actually doesn't matter. But if that had been a number, right, it changes things. So since I kind of have, the only thing being cubed here is the x still. So nothing's actually happening to the x. It's all happening to the y. All right, so I'm going to multiply my y's by a -1, and then this thing tells me to do what? The +1 on the end.
Move it up.
Yeah, I'll shift my whole graph up 1. Okay, so I'm going to start by, I'll do the purple first, multiplying the y's by -1. So what ends up happening on this one, that was at a +1, now it's now at a -1. My one that was at +8 is now going to be way down here at -8, and everything gets sort of flip-flopped like that. So there is me doing this part. Now in red, I'm just going to take that and shift everybody up 1. So please double check that your final graph looks like my final graph. And I cannot stress this enough, especially these ones that are actual parent functions and not just some random function, some generic function. Take a point and plug it in, maybe do 2, or, you know, if you want to do 3. If I plug in, according to my final graph, if I plug in 1, I should get out 0, right? Because that's a point on my final graph, 1, 0. So if I plug in 1, 1 cubed is 1, take the opposite is -1 plus 1, it is 0. Yes. You could check another one, plug in 0. Yeah, I get out +1, just like I should. It's such an easy check, right? To make sure you didn't multiply when you're supposed to divide, shift left when you should go on right. please, especially on a quiz or a test, take the extra 10 seconds. Okay, fourth. As I was quickly flipping through the homework, I saw some of you are not aware of what this parent function looks like, or you confused it with something else. I had some of those. So this is the inverse. Okay, this is the one that has those asymptotes. I'm going to use the green. You can't ever have an x value of 0, can you? Because then you get a 0 in a denominator. So we draw the asymptote there. Sorry, it's kind of hard to see. I'll try and make it darker. I'll just connect them. There's an asymptote. No, try orange. That might be better. A little bit better. Okay, you can never plug in. Phew, excuse me. Thanks. Uh-oh, got another one coming. Feel it. But then once you think about it, it goes away, right? And then it gets you when you're least suspecting it. All right, so I can't ever plug in 0 for x. What value will I never get out for y, therefore? 0. I'll never, no matter what you plug in for x, you'll never get out a y value of 0. So I end up having these two asymptotes here. The parent function, even if you forget what it looks like, would you just plug in numbers? Plug in 1. 1 over 1 is 1. Plug in 2, that'd be a half. And then hopefully you remember, oh yeah, it's just these ones that get like super close to the asymptotes, but they never actually touch. Over here. Sam, you with me? Where does the other piece go? I'll tell you what, it's not here, it's here. It's in quadrant 3. If I plug in -1, does the -1 come out? So I'd have the point -1, -1. This branch goes this way. So you have these two, a branch here in the 3rd quadrant and one in the 1st quadrant. That's what that parent function looks like. Now I ask you, what does this thing down here? If I have a -5 in there with the x, what am I really doing? What was that? Braylon, go ahead. Yes, to the right 5, which of course means my asymptotes move too. So you now end up getting, if I just pick this point up and I move it over to the right 5, I'm going to get one branch like this, and then the other one would have been right there. No, that was off the page, but there you go. Does that make sense? You can check a point. I claim that when I plug in 1, 2, 3, 4, when I plug in 4, I'm getting out -1. Do you? Plug in to the original function, plug in 4. Do you get out -1? Yes. Oh my gosh. So exciting when you get it right. 6. You guys know the parent function of this one, nice and easy. We've done a couple of these. That's just the V-shape vertex at the origin. There you go. All right, now let's talk about all these things happening down here. I got a lot going on. What do I have to do first? Braylon, tell me. Yes. See that coefficient of x? It's a -1 right now. It's supposed to be just a 1, not a -1. So what I have to do, everybody, is I have to factor out a -1 from in there. I have to. So in other words, I'm going to try and squeeze this in. I'm going to do it down here so I have more room. So if I factor out a -1 from inside that absolute value, I get -1 times x plus 2 minus 2. Right? Do you see that? I haven't changed anything. I just pulled out a -1. Now, since it's an absolute value, we can make our lives a little bit easier. Wouldn't that be nice? When you are multiplying things inside absolute value, right? If I take the absolute value of 2 times the absolute value of 3, you can actually split them apart. If you have 2 times 3 together, you would split them apart and take the absolute value separately. I can do that here because that's -1 times all of that. So wouldn't it make my life easier to do this? I still have this negative, that's still there, but I'm gonna split up this product. I'm gonna have absolute value of -1 by itself, absolute value of x plus 2 by itself. You see what I did there? Let me zoom in a little bit. Let me focus. Oh. You are, as long as it's a product, you can split up a product. So I did. And now I know the absolute value of -1. It's just 1, right? So essentially that kind of just goes away and I end up with this. That negative is still there from before, x plus 2 minus 2. You don't have to do that part, but I mean, why not? Just make things simpler. And why does that work? Think about it. If I have the negative in there with the x, I'm dividing all the x's by -1, which essentially just flips it over the y-axis. But look at my graph. Look at my parent function. If you flip it over the y-axis, doesn't it look exactly like it looks? So that's why it doesn't matter if you do it or don't do it. So I'm going to end up with the same thing anyway, as long as I do it right. So let's go ahead and follow all the pieces. I might be able to do this all in one step. I don't know, maybe not. What is this negative on the outside going to do the whole thing? What do I do with that? Yes, my y's get multiplied by -1, which essentially just flips it over the x-axis, right? So I'm going to flip upside down. I'll do that in purple. Okay, and then the shifts I can do in one step. What does a plus 2 in there do? Left 2 and what's this? Down 2. So for my final graph, I'll take this one that I flipped over and go left 2, down 2. So that red is my final graph. How about that? Let's check a point, shall we? Let's say I plug in, so here's a good point. If I plug in -2, I expect to get out -2. Always plug back into your original, just in case you made a mistake down here. So if I plug in -2, let's see. That becomes +2 minus 2, so that's 0. Opposite 0, 0, minus 2. Yep, I plugged in -2 and I got out -2. So yes, I know that's a correct point. You can plug in more if you want. I'll plug in this one too. If I plug in -1, I'm expecting to get out -3. Let's see, -1 in there turns into +1. 1 minus 2 is -1. Absolute value is 1. Take the opposite is -1 minus 2, -3. Yes. Did you get it? You have the right graph? Oh, I'm so happy. Okay, back. Yeah, so these ones you didn't have the parent function. I mean, you could have drawn it on your own, but they weren't asking you to draw that first. So this one, I like how this one actually put the parentheses here, because then it's very obvious that this thing does what? What does that negative on the outside do? You're right. I think it's so confusing to think of it that way, but I mean, if that works for you, you do it. It's essentially the same thing. I'm multiplying all my y's by -1, which does flip it over the x-axis. Okay, so there's one thing. Multiply y's by -1. And then the +3 just shifts it up 3, right? That's not bad. 3, what's the parent function here? What's the parent? Yes, it's just a parabola. I can do all this in one step, I bet. Is the parabola upside down and then just move it up 3. So just pretend that that's the origin now. So I'd go this way, then I'd go 3 over 1, 3 over 1. Boop. Did you get it? Check.
I did.
You can plug in a point, plug in 0, I get out 3. Cool. Plug in 1, I get out 2, just like I should have. Yes. Another parabola parent function. What does this do? That thing does what? To the right 2 and down 4. That's it. So just take your normal parabola, right 2, down 4. 1, 2, 3, 4. So that's now my vertex. And then 3 over 1, 3 back 1. There it is. Oh my gosh, once you unlock the secrets to these, they get pretty easy, hopefully. If I plug in 0, I should get out 0. I do. I get 4 minus 4. Yes. Okay. Do you remember what the parent function looks like for 10? I'm going to draw this one. This one maybe you don't know. Yep, really?
Start at the origin.
Yes. Yep. You got it. Yes. By the way, on some of your guys' homework, I'm seeing you giving me like so many ordered pairs. Why? What does that do? Someone that gives me all the ordered pairs. There was a few of you. Does that help? What is it? Or do you
Oh, I did that.
you think so? So you do the transformations to the numbers
Yeah.
and then you plot the numbers? Oh. I have never done it that way, but I could see how it would be way less chaos on the graph. Hmm. All right, any hoosers, what does this do? Quick, tell me, this thing on the outside.
Once it over the.
You're right, but yeah, we're multiplying our y's by -1. What does this +1 on the inside do? Left 1. Perfect. So this thing should end up being y's by -1 is going to flop it upside down. And then you're going to the left 1. So you'd have this graph. This is your final graph that I have here in purple. Upside down, left 1. Plug in a number. If I plug in -1, I should get out 0. I do. Oh, I'm so glad that this one is what this one is. So I wonder how many of you did the wrong thing on this one. What should I do first? Evan? Yes. You got to pull out that -1. Same thing. Take that out, and then you'd have x minus 5. So now, what does this do? Having that -1 in there with the x, because it's under the radical, right? So everything under the radical is going to happen to the x. If it were outside of the radical, it would happen to the y. So this is under the radical. So if I have a -1 times blah, blah, blah in the radical, what does it really do? Cedric? Yes, I'm going to divide my x's by -1, which for those of you reflective people, that puts it, I'm reflecting it over the y-axis, right? That would be the same thing. And then this is how I'm going to know if you remembered to pull out the -1 or not. Because if you went to the left 5, that's incorrect because we should actually go to the right 5. Check your work. So you should end up, let's see. So if I divide all my x's by -1, that's going to give me this graph. It's going to go backwards this way. So there's that. Oops, I missed that last. There's that first step. And now I pick that up and I move it to the right 5. So this is going to end up all the way over here. Does that make sense? So that red, this is my final right here. check a point. If I plug in 1, I'm expecting to get out 2. I do. So I get the square root of 4, but just 2. So if you, this is what I'm saying. If you take the extra 10 seconds to plug in a point, if you went the wrong way, you would find your own mistake and you'd say, wait a minute, if it's a +5, I'm supposed to go to the left 5. Why am I not doing that this time? Why didn't this work? And then you realize, oh, the coefficient of X isn't +1, it's -1. Of course, I have to factor out a -1 first. See how you caught your own mistake? You're so good. I should just call you Sherlock Holmes because you solved the mystery. Anyway. Last one. This one's, the first one's super easy though, right? I'm just gonna take that parent function and I'm gonna go where? What do these do? Quick, 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 tell me. What does that and that do? Left 4, down 3, right? I knew what you meant. Left 4, 1, 2, 3, 4, down 1, 2, 3. And then you just have your normal absolute value. Okay, fine. This one, little bit trickier. What does that negative outside the absolute value do? Yes, I'm gonna multiply my y's by -1, which essentially flips it over the x-axis, and then the +1 on the inside, left 1. So it goes this way. There we go. Make that line straight. Check a point. If you plug in -1, I should get 0. I do. Plug in another point, plug in 0, I should get -1. I do. What do you know? Any questions on the homework or doing any of these? This feels okay? Do these all class? Well, you're gonna like writing the equation, I think. Let's give that a shot, shall we? Okay. So I think I'm gonna stop the video and then start a new one. So there's kind of separate topics. Yes, I'm gonna do some together. Get it done in class.
No, what? Yeah. We were not with the partner.
You don't know how to do it yet.